Okay, hello, it's me. We'll see how long this is because sometimes if it's too long, it takes forever. But welcome. The big thing with 7.6 is that you need to know when to use the binomial distribution and then the two different kinds. So we talked about discrete before, and then we'll also see continuous. So here's like the two examples, and this is what it looks like in your calculator, like these words here, binom BDF or CDF. The first thing we're going to do though is finish up 7.5, which is expected values. Please try to have 7.6 completed by like in 2 class periods, if that makes sense. I forget the days and the locations, but it's like Mr. Mauer's room, I think, always and forever. So please, if you get stuck, go see them. Okay. So some of my sections, some of you already finished this, but some of us didn't. So one, please watch the video. It's a really good job. It does a really good job of explaining it. It's rather quick. The big thing with expected values is that it's from the mean. Your mu is your mean, right? And remember that like we add up to find our mean, so that's why this sigma is here, right? Because that would be like a sum. So this is an example. A newsagent talks about delivering 6 copies of a newspaper. This is a very antiquated thing. Newspapers are a dying entity, but so it like has you. So 3 newspapers. They collect data, predict, right? So like I would want to predict something. So I have S, I have 2, 3, 4, 5, 6. And then I have the probability that it's like I sell 2 of those newspapers, or 3, or 4, 5, or 6. So it says find the expected number of newspapers sold and interpret its meaning in the context. So expected number, E of S, is 2 times 0.5. So I'm going to multiply and then add. Right, so like I'm finding my average. And you can use that big fancy equation. However, I would just use my calculator. It's not too horrible. So when you do that, it comes out to be 383. That's 3 significant figures. Okay, so this is not the probability, right? So 3.83 means that it's somewhere between 3 and 4, right? Somewhere there. So what this means is that on average, the newsagent should expect to sell more than 3 newspapers, although 3 is the most likely outcome because it has the highest probability. So I'm going to say this means on average, right, because it's dealing with averages, the newsagent, again, this is like an antiquated thing, should expect, right, it's about expecting, to sell more than 3 newspapers, although 3 is most likely, right? Because 3 is 39%. Okay, so va, that's good. It also means that, so I think about what's left over here, right? There's more than a 50% chance that she will sell more than her regular order, which is great, right? But generally I should expect this number. So that's expected value. It's not, you do not get a probability out. You get your variable. Okay, next. This one is funny. This is a funny problem. So one thing that's happening is that you have 2 unknowns. And it tells you your expected probability, or sorry, your expected value, sorry. Ooh. And then you need to find the missing entries, right? and then find the probability distribution. And it tells you that it's linear, right? So like tells you all these things, you have to work backwards. So one thing about this, I'm going to shrink it for a second, is that like, what are you given? What is given? What do you need to find? Do you need to find? Okay. So for A, what did I do? I was annoyed that there wasn't like a common denominator, so I made mine be 40s. So just like for the record. So in order to do that, I did, those are ones. So 1/4 I made to be 10/40ths. And then I said this was X and this is Y. So this is X, this is Y. You can make them be whatever you want. I think the book makes them be something else. And then 5/8 instead of 1. Oh, sorry, not 5/8. 5/40 instead of 1/8. So all of that should equal 1, right? Because it's a probability entry thing. So what did I do? I added up, I like moved everything around, right? So like I wanted to get, I'm going to do an arrow, X plus Y, because you're going to need a system, basically. 1, and then minus all this other stuff that I had just written. Minus 10/40ths, minus 5/40ths. So when I do that, I get this. It's 14/40ths. Again, like when you use a calculator, it's going to give a decimal. So remember that you can, do math, and then what does it do when you push math? 1 is for fraction, to get a fraction back. Okay, anyway, that's also 7/20ths, if that helps, if you want to use that. The other thing that we know is, I did not do a good job in my notes of keeping this ordered. Oh, oops. So then I can also, I know my expected, right? So like, I know this. Oops, that's not a W at all. So I'm going to use that to find my other equation. So same thing, I know that 1 times 11/40ths, this is going to be kind of long, 2 times 10/40ths, 4 times X, right? Remember, because I don't know that one, 6. Also, this is not going 1, 2, 3, 4, just in case that happens to you. 5/40ths. And I know that that equals 67/20ths. I'm going to write this over here. Which, in case you were wondering, I know you are, is 134/40ths. You can leave it in 20ths. I just was being difficult. Okay, so that's my expected value, right? Like I know that. So then once I sort of organize this all together, you multiply, right? And add, what did I get? I'm going to show both steps. I got 66/40 plus 4x plus 4y equals 134/40, which simplifies to, there's an arrow, 4x plus 6y equals 68/40ths. Saba. So when I use a system, so I'm going to say, what do I want to say? I'm going to highlight these. Hold on. I guess you're not going anywhere. Don't go anywhere. 1 and 2. Yeah? I'm going to make these be blue, actually. Hold on. Perfect. So I'm going to say, use system to solve. Okay, are you having fun yet? Did you hear my page turn? Because that's where we're at right now. Oh my gosh, my notes are so messy. Okay, this is good. It's been a while. I'm going to move this up for, well, yeah, it's fine. Everything is fine. I'm going to keep blue. Okay, so I'm going to use substitution. So I'm going to say 4x plus 6, parentheses, 14/40 minus x equals 68/40, which is a very fancy way. I'll show my steps just in case anyone is joining us late. Minus 6x, because I would distribute, equals 68/40. If you're rounding, remember that you might have rounded once or twice or 3 times, so just be mindful if you're rounding with a decimal. Okay, because I'm gonna like move x's to one side, so that's 68/40 equals 2x. 16/40 equals 2x. You get 8/40, or 1/5. Oops, not 1/50. That would be different, bad. Now that you know that, right, plug into your equation. So I'm going to say 8/40. Wait, no. Yeah, sorry. 8/40 plus y equals 14/40. So y equals 6/40, which is like 3/20. Whatever you want to use. Live your life. I'm just here using 40ths. Okay. Yeah? So, what does this tell us? Got a great question. I wish I knew. Just kidding. It tells us our table entry. So I'm going to go up here. I'm going to erase this. And then I'm going to plug in, oh gosh. I'll use 1/5. What was that, 3/20? Just because they used all sorts of different stuff. I'll join the chaos. Okay, so that's part A, right? Good job. Right, we did that. And then it says, oh wait, no. Determine the missing, find the function. Oh, that's why I had that on there. Okay, so find function. I know, hear me out. This, remember, it was like you were finding from the table. So I'm going to rewrite my table. My money, my probability of big X equals little x. So this is 1, 2, 4, 6, 7. Okay, so one thing you can do, hear me out. It tells you that it's a linear function. So you could enter this into your lists and then find the regression. I'm just saying. Those are American ones. Oops, that's a 0. Okay. So here I'm going to write in 40ths because there should be some sense of cohesion in the world. So let's get dark green, actually. Okay, so one thing, it tells us that it was linear, right? It told us that. If it wasn't, then this would be more annoying than it already is. So I know I want y equals mx plus b, or ax plus b, or whatever the calculator tells us. And remember that I'm thinking about how to take my input x and make it be my output. Yeah? So the first thing that I'm noticing, right, is that it's divided by 40. Yeah. And then remember we did this in class. So like 11 and 1, 10 and 2, 8 and 4, 6 and 6, right? Those all have like a 12 happening. I'm not adding, I would be subtracting. So this is 12 minus x. I already know the answer though, so I'm not a very good liar right now. But here's what I did to check. You could enter, so L1, L2, and then do a linreg because it tells us, right? So let's remember that's number 4. And it will tell you, it gives you like decimals. I know, stoked. What was it? It was negative plus 0.3. So you can use your calc, is what I'm saying, if it's linear, right? But otherwise, you're like playing sort of like guess and check. Okay, so that is what you do for that. I'm going to go to the next. See, it gets kind of wacky. I'm going to do a new page for part B. Okay, so part B says, find your expected value. The thing is that it told us already that it was 67 out of 20, right? So like, I'm not really sure why it's doing this. And then it's like, what should you charge? Or wait, hold on. What does it say? It says something like that. So what I did is I like reran everything. So I said E of X, get that out of here. Right, so 1 times 11 divided by, oh my gosh, you guys, I'm so sorry. Oops, plus 2 times 10/40ths, plus 4 times 8/40ths, plus 6 times 6/40ths. Because those, remember, were my X and my Y, so I didn't know them, but now I know them. 5/40ths, oh please, sorry. So that equals, right, we already know this. I've already told us this, so I'm not sure what's happening here. Which is 3.35, and remember that that is dollars. It's not probability. So the book in the key, it said 77 out of 20 instead of 67, so I'm assuming that's a typo, because why would there not be a typo? So typo said 77 out of 20. That is not true, and if it is true, it changes the whole problem. So please don't use that number. What that means is that if you're trying to make money, you should charge more than that, right? So charge more than expected value. Right, so if I charge $3, right, and my expected value is $3.35, then I'm gonna like lose money on this game. Value. So to be safe, this is like a corporation writing this problem. Charge $4. Oops. Hold on. Charge $4. Yeah. Kind of. Okay. Smile. Next. Oh, yes. Okay, number 1 is not bad. It looks worse than it is, but it's not. Number 2, you have to... Number 2 is not bad. Number 5 is kind of tricky. Okay, do I have space for this? I don't have space for this. I'm going to do this. Hold on. No. Okay, I'm just going to do number 1. Wait, no, I'm not. Okay, I fixed it. Well, we'll see about that. So this is just like a super abstract problem. And so when I say that it's like, there's no context, right? There's no dollars, there's no winning, there's no newspapers. It's just like some random problem. So the discrete random variable b has a probability distribution function given by p of big B equals little b equals k times 4 minus b for all of the b's that are 0, 1, 2, 3. Find k and e of b. Okay, let's do this. So one thing that I'm going to have you do is make a table. Make a table, when in doubt. So I have my little b's, and then I have my probability. Boop. Boop. Someone's going to be like, is that a 6? No, it's a B. Okay, leave me alone. We've got 0, 1, 2, 3. That doesn't need to be so big. Okay, so, oops. I have this little equation, so I know some things, right? One thing I know is that if b is 0, right? If b equals 0, then I have k 4 minus 0, which is k times 4 or 4k. So that's 4k. B equals 1, 3k. B equals 2, 2k. 3, 1k. Yeah? When you plug in, right? So this is like our input. Okay, so that's my table. The next thing, so here maybe I'll do like a little 1. The next thing that has to be true, right? 2, is that 4k plus 3k plus 2k plus k has to equal 1. Kabish? When you add all these up, you get 10k. When you solve for k, you get k equals 1/10. Those are ones. Okay, so because I know that, I'm going to draw like a little arrow. 3, P of big B equals little b equals 1/10 times 4 minus b, right? So that's my equation. My like my distribution function. Yeah? Okay, one way to also write this, 4 minus b divided by 10. And that's sort of similar to how we've been writing our equations when we have to like find them ourselves. So just in case you were trying to make that connection. I don't know what you're doing. Okay, so we found k. Now we need to find e of b. So I'm going to go over here. So e of b, my expected value, is, oh, I'm not going to have space. I'm going to zoom enhance. It's my table, right? 0 times 4k plus 1 times 3k. Oh, man. Gotta do this. Shucks. Plus 2 times 2k plus 3 times k. That was okay. Here, I'm gonna like do a little weave there. Okay, what does this tell us? Yeah, but I know, oh, I already know, shoot, I didn't do this. I meant to make another table. Right, because I know my k. Dang it, I was doing so well. B, 0, 1, 2, 3, probability b equals b. This is 4/10, 3/10, 2, yeah, why am I, and then this is 1/10. Oopsies. Okay. So, my bad. 0, 4/10, 1 times 3/10, 2 is 2/10. Oops, oh my gosh. 3 times 1/10. The 2 and 2/10 messed me up. Okay, so that one's gone, right? So when you do all this, I'm going to just show this for a second. 3 plus 4 plus 3 over 10. That equals 10/10. And that's fine. We're fine. Everything is fine. So my expected value is 10/10 or, oops, shoot, 1. N'est-ce Okay, remember this is not my probability. It means I'm here. I'm at 1. So, E of b equals 1. So you would expect for this function, like this random variable probability distribution function, your expected value is 1. So that means that's where most of the things are happening. If you... Wait, yeah, that's it. Never mind. That's it. We're finished. Oh my gosh. Next. Okay. This is my little hint here. I'm going to reset. This, you need to have done the other problem. So if you haven't done this, then you have to go do it. Sorry, but it's true. Let's do pink. So, and it was about the gender binary. It was your triplets, right? So, if you, again, you have to go, like, look at it. But your males, probability of big M equals little m. You remember that the ordered mattered, so you can have no males, 1, 2, or 3. So you have 3 out of 3, right? Triplets. So when you look at the distribution, 1/8, remember there's 8 options. This is like, we looked at a similar problem in class with the coin flipping thing. 1/8. So one thing is that like this is the same as F, female, for the same like problem. So it says find your expected number of male births. So that means that we do E of M. So I use my table, 0 times 1/8 plus 1 times 3/8 plus 2 times 3/8 plus 3. Right, again, you could use your calculator. I'm going to do this, 3 plus 6 plus 3 all over 8. This equals, sequasa, 12. Okay, so remember this is not our probability. So you're like, oh, it's greater than 1, that's wrong. It's fine, it's not the same, it's not it. This equals 1.5. So that means that you're here. You cannot have 1.5 males, I don't think. Again, the gender binary is stupid anyway. So one thing is that like E of M plus E of F should equal 3, right? Because 3 triplets. So 1.5 plus 1.5 is the same as the females, right? So like that has to be true, even though it's not like possible. But one thing to know is that like it seems most likely to have 1, 2 males rather than 0 and 3 for a set of triplets, right? Remember the context. Okay, that's how you do that. Expected value, you add them up. Okay, next. Okay, this one had a hint. It was like, how much of the circle does each letter take up? Yeah, I know. It's asking if the game should cost $5 to play. 1, no, because what even is this? But 2, we will go through the motions. Remember that if X is the gain of a player, E of X equals 0 means it's a fair game. We're not really, like, it does talk about a fair game, but we're going to talk about, like, if the cost is, if it is good. Okay, so should it cost $5? One thing that we need to recognize, I'm going to use a little highlighter here, is that this and this, oops, maybe I should have done that, oops. These are equal slices, right? They're 1/8. Oh, I got rid of my, this is 1/2. And then I'm going to make this be purple. That's 1/4, right? So I'm going to, let's use black. So I'm going to say this is like 1/4, 1/8, 1/8, and 1/2. If we were in class, I'd say, how do you know that those add up to 1? It's one whole circle. Yeah. Okay, so then we're going to find our expected value. And then we'll talk about if the expected value is going to like tell us anything about how much the game should cost. So the expected value, E of x, I'm just going to say, is 3 times 1/4. 7, right? Because these are the prizes, right? So this is like, in theory, I'm going to get $7 if I land there. Like, that's a good deal. If it only costs 5, I made $2. But we'll see. What am I doing? Is 1/8 $5, sorry. And then 2 is 1/2. Capiche? Okay, so I must have done this in my calculator. I have a medium step. So this equals 3.25. So your expected value is 3.25. So that, again, is like how much I'm going to win. This is my prize. Prize money. So given that it's asking if I should like charge $5, right? No, because the expected value is $3.25, right? So that means I'm going to lose $1.75 each time. The game should be cheaper. Like maybe I don't know, $3. I'm not sure. But okay, so is the game fair? Wait, no, right? Because 3.25 does not equal $5, right? So like that should equal 0, and it doesn't. Okay, great.